welcome to our beloved lecturer, which is Sir Habibullah, and fellow friends. In this video, we are gonna to explain application of polynomial function in daily life. As we know, polynomial function is applied in areas such as engineering, design, healthcare, forestry, or electronic. As an example, we discuss about the trail of roller coaster in the part of design. So, the equation for a part of roller coaster is negative 0.4 times x power of 4 minus 22x cubed plus 145x squared minus 300x. So, we set the domain for this equation is 0 to 12. First step, we must remove x from this equation. Next step, we must find the root for this equation, and we do division for this equation, and we get the simplify of this equation, which is negative 0.4x times x minus 5 square times x minus 12. So now we want to find y-intercept and x-intercept, which is we substitute x equal to 0, fx equal to 0, and we get a y-intercept which is 0, 0, x-intercept which is 0, 0, 5, 0, and 12, 0.
Okay, next I will be continuing on finding critical points. So this will be our equation. So from this equation we will be doing the first derivative. For the first derivative we will get negative 0.4 4x cubed minus 66x squared plus 290x minus 300. So from this we will be simplifying into negative 0.8 2x cubed minus 33x squared plus 145x minus 150. So from this equation we will be using calculator to find three roots. So we will get x1 equals to 1.5, x2 equals to 5, x3 equals to 10. So from here our equation will be negative 0.8 2x minus 3, x minus 5, x minus 10. So to find the value of y, we will be substituting x into this equation to get the y value. So the y value will be 77.175, y2 will be 0, y3 will be 200. So in conclusion, our critical points will be x 1.5, so the y value will be 77.175. Second, x2 equals to 5, then y2 will be 0, x3 equals to 10, then y3 will be 200.
Okay, after we get the critical points, we need to find the intervals, which is 0 to 1.5, 1.5 to 5, 5 to 10, and 10 to 12. And then you have to test the sign for f prime. For the first interval, we take the number between 0 and 1.5, so we take 1. For example, f prime 1, we substitute x equals to 1 to f prime, so we get the answer 28.8, which is greater than 0. For the next three interval, we have to use the same steps, so we get this positive, negative, positive, and negative. When the sign is positive, the graph is increasing at interval 0 to 1.5, and when the sign is negative, the graph is decreasing at interval 1.5 to 5. To conclude, the interval 0 to 1.5 and 5 to 10 the graph is increasing, and the interval 1.5 to 5 and 10 to 12 the graph is decreasing.
So this is a first derivative equation. And this is from the first derivative equation, we find the second derivative equation, which is negative 0.8 times 6x squared minus 66x plus 155. To find the root of the second derivative equation, we use this formula, and we got the root of x is 3.034 and 7.966. Okay, from the value of x, we can find the inflection point by substituting the value of x into the first equation. We got the inflection point at 3.034, 13.892, 862, and 7.966, 40.195. So after get the inflection point, we substitute the value, any value below the 3.034, and we got the positive value, means that the graph is concave down. When we substitute the value of x between 3.034 until 7.966, we got the negative value, means that the graph is concave down, concave up. So when we substitute the value of x is larger than 7.966, we got the positive value, means that the graph is concave down.
So from the critical point that we find just now, 1.5, 77.175, 5, 0, and 10, 200. We can find the maximum and minimum point by substitute the x value of critical point into the f double prime x. So first, we try about by substitute x equal to 1.5 into the equation. Then we got the final answer as negative 47.6, which is smaller than 0. So it means that it's a maximum point. Then we do the same thing for the x equal to 5 and x equal to 10. So we get the conclusion for maximum and minimum point as the maximum point is 1.5, 77.175, 10, 200, and the minimum point is 50. So next we can sketch a graph by using the x-intercept, y-intercept, inflection point, and the local maximum minimum point. Then the final graph is like this. Is x-intercept, y-intercept, local maximum point, local minimum point, and inflection point.
Okay, in conclusion, 0, 0, 5, 0 and 12, 0 will be our x-intercept, and 0, 0 will be our y-intercept too. And interval increasing will be 0 to 1.5 and 5 to 10, and interval decreasing will be 1.5 to 5, then 10 to 12. Then the inflection point will be 3.034, 42.057 and 7.966 and 113.078. Then the concave up will be 3.034 until then will be 7.966. Concave down will be 0 to 3.034 and will be 7.968 until 12.